Good evening, this is the presentation of our work entitled Comparison of Multivariate Time Series Clustering Methods. The authors are Iago Vázquez and Javier Sedano from the ITCL, Instituto Tecnológico de Castilla y León from Spain, Svetlana Simic from the University of Novi Sad in Republic of Serbia, and José Ramón Villar from the University of Oviedo, Spain. We are going to cover the problem description, the comparison of the different techniques, the experimentation and results that we have obtained, and finally the conclusions. Multivariate time series is a program in which each of the instances includes several variables, and each variable is a time series itself, a univariate time series itself. When we need to cluster these kind of instances, we find the problem that there are some variables that are quite similar or that behave similarly for two instances, and then different set of variables perform similarly with a different between two other different instances. And there are some variables that are related within themselves and some others don't. So we need a method that considers this kind of information, but also consider other factors such as the shape or statistics, etc. There is no single or easy solution for this, and the main of the problems are problem dependent. Typically what people have done is to use a univariate time series representations such as APCA, and then perform a univariate time series clustering and somehow made an aggregation. In this case, we show here the APCA which is a time series representation that divides the time series in interval, calculates the mean value, let's say, for that interval, and so make a simplification of values that we need from the time series. So we have finally a square shape time series. The same happened with a hard wavelength. We have some most representative, let's say, time series vectors, and we make a combination of them, or we use a discrete Fourier transformation, etc. In each of the cases, we use a distance measurement that works well for the problem. In this story, we have implemented several multivariate time series clustering algorithms, either by extending univariate methods or coding existing multivariate algorithms. And then we tested them using public multivariate time series datasets. The first two methods make use of APCA at the piecewise constant approximation, but in the first one we use a mean distance, in the second one we use a dynamic time rewarping. And in both cases we use the hierarchical clustering. The second set of or pair of methods make use of fast Fourier transform. So we move from the time domain to the frequency domain, and we use the energy as the distance measurement, and we keep the hierarchical clustering. And finally, we use the raw data that is no time series representation at all, and the compression-based dissimilarity measure together with hierarchical clustering. This is a multivariate time series clustering methods. For experimentation, we use 5 data sets. We can see the results, or the main characteristics of in this table. This is the articulatory word recognition, the cricket, the epilepsy, the finger movement, and the heartbeat. And you can see that there are a variety of number of variables, number of levels, the number of samples that each of the time series includes, and also a different number of training instances and testing instances. As performance measurements, we use the accuracy, the sensitivity, the specificity, and the kappa factor, and we use the typical counters, but we aggregate the results for all the methods right? So these clusters are the aggregation of the results of each of the instances against the other from the dataset. We ran two different experiments. The first one, we left the number of clusters vary, and we used the rule of the elbow to determine the best number of clusters. And if you pay attention to the remarked results for the articulated word recognition and the cricket, the APCA methods perform very well, finding the number of clusters, which is very similar to the number of classes. And on the other data sets, well, there is no clear winner. And for the concerning with performance measurement, we can see that they are still problem dependent, although in many of them the APCA perform pretty well. And when the APCA perform decreases its performance, the last methods increase its performance. So well, let's say that it seems that the APCA and the CMD methods are complementary. When we run the experiment using the same number of clusters as the number of levels, what we find out is that for the articulated word recognition and cricket, all of the methods perform pretty well, but maybe worse the CMD. But when the performance of when the performance of the APCA decreases, the performance of the CMD increase. So it seems that the methods are still problem dependent, and we need something that can take advantage of when one of the methods is performing well, to consider those as the best candidates instead of the others. So there is still room for improvement with the time series clustering and perhaps some embedding, some ensembles. As a conclusion, we can say that there is strong variability according to the dataset, and that there is no clear winner in all of them. The APCA and the CMD based clustering seems to be counterparts, and perhaps what we have said, maybe introducing an intelligent ensemble of this technique that consider some information about how good each of the methods is performing could help to improve the grouping process. And this is all. Thank you so much for your attention. I'll be glad to answer any question you have.